Hello, my name is Aryan Zahir, and this is the first assignment for computer systems where I'm supposed to make a circuit to obtain the functionality of a stopwatch. Here in stage 1 we can see that we have used a toggle flip to keep track of the start and stop time, as we can see over here, and the toggle flip starts working, uh, and we can see the clock is started in this LED and the seconds are being counted. In stage 2, I have used JK flip-flops. I used 4 JK flip-flops here to count from 0 to 9, because I would need because to hold the value of 9 I would need 4 bits. And for ensuring the seconds display over here, let me start the clock real quick. And to ensure the seconds display over here, uh, I used an AND gate. I used an AND gate over here, which would which takes two inputs, one from the toggle flip and another from the clock. In this case, the toggle flip works as the control bit and controls the flow of the clock. Then for the counter, uh, the first JK flip-flop takes input from the toggle flip and the clock. The second JK flip-flop takes the input from the first flip-flop and the clock as well, and when the first and second flip-flop both pass in the value 1, then it feeds this input into the third flip-flop. When the second and third flip-flop both pass 1, the fourth flip-flop gets activated. When the fourth and second flip-flop are 1, then again the whole counter gets resetted. In stage 3, for the double digit second, I have used 3 JK flip-flops. The first flip-flop gets active when the fourth flip-flop of the single digit, this one passes 1, meaning when the counter reaches 8. And the AND gate could be used to make the AND gate could be used to make the first flip-flop get used to make the first flip-flop get active when the single digit counter would get to 9. But when the counter reaches 8, the counter reaches 8 using the D flip-flop, I slowed down the signal to make the flip-flops active. I used this method first and it works, which is why I didn't change it. But when the counter reaches 6, it resets all the flip-flops. I used D flips, and with the output to make sure that the counter never displays more than 5 in all the counters. All the D flip-flops input the clock. All the D flip-flops input for the clock is connected to the clock directly. Now coming to the reset button, let me start the clock. Now coming to the reset button, I have added all the T and D flip-flops. However, to connect the JK flip-flops to reset, I added an OR gate over here with the existing reset system. Now coming to stage 4, start the clock. Now coming to stage 4, we can see that I have added the same setup as stage 2 here. Uh, the difference is that these flip-flops only get active when the single digit flip-flop reaches 9 and the double digit flip-flop reaches 5, meaning 5, 9 or 59. The added D flip-flop add delays output and the minute increments only when the second reaches 0, 0. The reset start and the reset start and the reset start stop function works same as stage 3 over here. And this is my whole circuit, since I could not finish stage 5 and 6, since they made my circuit uh, unfun- un- since that couldn't make my circuit function properly, so I decided to not use that. So here we can see that my clock works over here in 1 hertz. It work and if we press reset, the clock will reset over here, so this works fine. And it can also start, and by pressing Ctrl K we can start the clock as well. So yes, this was it for me, and this was my whole circuit that I have made for this project. Thank you very much.